All right, welcome back to Good Choices. I can say that with confidence. I haven't made a LPIC video in like 2 days. That's okay. Sometimes you just need a break, but can't let this sit for too long because, especially since I'm so close to the end and being able to take the test. So sometimes, you need a break. Um, but hey, and, we got to skip 4.3, so let me try something quick. I'm just curious. So we've got 4.5. Let me just try changing the URL to 2.4 because I'm just wondering what's going on. If they're like, okay, so that's good. So it looks like there is one. It is actually, yeah, okay, good. I just thought like maybe there was an error here, and that one does exist, but it looks like if you just change it to dot four, there truly isn't a dot four for some reason. All right, so there we go. We're at point five. We're still talking about devices, Linux file systems, which are different than partitions, what we learned about before, different from disks. And then the file system hierarchy standard, which I don't think we've gotten to yet. So the objective for this one is to manage file permissions and ownership. And yeah, this is .5, so we just got to get through this 6 and 7. Then we can take the first first exam. So this looks like a pretty long one. Might take me a few parts, but let's get started. So, introduction. Being a multi-user system, Linux needs some way to track who owns each file and whether or not a user is allowed to perform actions on a file. This is to ensure the privacy of users who might want to keep the contents of their files confidential, as well as to ensure collaboration by making certain files accessible to multiple users. This is done through a 3-level permissions system. Every file on disk is owned by a user and a user group and has 3 sets of permissions: one for its owner, one for the group who owns the file, and one for everyone else. In this lesson, you will learn how to query the permissions for a file, the meaning of these permissions, and how to manipulate them. Querying information about files and directories. The command ls is used to get a listing of the contents of any directory. In this basic form, all you need are the file names. So here we go, ls, and then another underscore directory, picture.jpg, and then text.txt. So there we go. But there is much more information available for each file, including its type, size, ownership, and more. To see this information, you must ask ls for a long form listing using the -l parameter. So ls-l, and now we get the extra information here, and we get them in a kind of a more useful, more intuitive format where they're each in their own line instead of all on the same line. And we get all the extra information. The permissions are here. I'm not sure what this is, but this is the who owns it, which user owns it, which corresponds to these permissions here. The group it belongs to, which corresponds to these permissions here. And then these permissions are regardless of the owner of the file or the group that the file belongs to. So like if I create a file and I want to share it with people, and I want them to be able to read the file, but I don't want them to write it, we can remove this, and then we can add it to the group where everyone's in. And then if I want it to be secret, then I can remove the write. So the only people that can see the contents of the file are either myself or those that belong to the same group as me. So like who I'm sharing it with. So that's another thing that's kind of nice about Linux over Windows is like this permission stuff is, for people new to Linux, like look at this. Like this is not clear what's going on, but it's like, yeah, you got to learn it. It's not super intuitive, but once you do, like, I think the permissions in Linux are like a lot easier to work with than they. I don't even know. Like I took a number of Windows classes when I was in my 2-year school, so like I know there are there are a lot of like permissions, like kind of like in Linux, but like a lot of it is I think even less intuitive than with Linux. So I've definitely learned all about Windows permissions at one point, but I think it's a bit more easier to work with on Linux. All right, so each column on the output above has a meaning. Let's have a look at the columns relevant for this lesson. The first column on the listing shows the file type and permissions. For example, on so here's the file type and permissions. So file type is it's a directory. This would be a dash if it were just a regular file. Now we've got the permissions for the owner, for the group, and for everyone else. So the first character, D, indicates the file type. The next 3 characters, RWX, indicate the permissions for the owner of the file, also referred to as a user or U. The next 3 characters, RWX, indicate the permissions of the group owning the file, also referred to as G. The last 3 characters are -X, so notice how there's no writing permissions, indicate the permissions for anyone else, also known as others or O. And I like how they do this because you can imagine the command being fed like a -D and then like feeding it these 3 or like any combination of these for modifying the permissions. I like how they set this up like that, assuming that is the case. It might not be. All right, so tip. It is also common to hear others permission set, the others permission set, so the last 3 here, referred to as world permissions, as in everyone else in the world has these permissions. So you can see how those are the really important permissions to have correct, because anyone can see it. So if you accidentally have a write here, anyone in the world can write to that, and that might not be what you want. The third and fourth columns show ownership information, respectively for the user and the group that own the file. So the third and fourth columns. So 1, 2, here we go. So yep, they're talking about these. So the third and fourth columns, 3, 4, show the ownership information, respectively the user in number 3 and the group that own the file, number 4. The 7th and last column shows the file name. So 1, 2, I'm not sure what this is, 3, 4, 5, 6, 7. So there's 7 columns, which might be a bit confusing because we've got this here, but this is one column. But you could think that it's the date and then the time in a separate column. But since they're saying 7th, 1, 2, 3, 4, 5, 6, all 1, 7. So this is just one column here. The second column indicates the number of hard links pointing to that file. Okay, so that makes sense. The 5th column shows the file size. so the file size is here. The sixth column shows the date and time the file was last modified. But these columns are not relevant for the current topic. I mean, for the current topic. This is an important one to know because sometimes you want to order them by the time. Let me pull up the lab and just demo that, because that's like a practical Linux thing that can help you here and now if you just want to see the last modified. So what do? I think everyone's familiar right now. So ls-help, and then look through them. So here we go. -t, sort by modification time, newest first. So now you can do an ls-t, and you can see which ones have been. And if you do a -tl, now the time will show up, and you can see this one here I modified 2 days ago. So sometimes it's really useful to look at it this way. So that's a here and now actionable thing, this -t, ls-tl, that I think will help a lot of people. So I just wanted to take that quick tangent. So let's get back on topic. Okay, so what about directories? If you try to query information about a directory using ls-l, it will show you a listing of the directory's contents instead. ls-l, another directory. So okay, so this is what they're saying. We have a directory here, the more student directory. Let's change into it. All right, let's see the files there. Okay, now let's do an ls-l. And now we can see the directories in it. They are directories. They have permissions. So, and we can see everything in the more student. Okay, so now let's go back. Let's do an ls-l and feed it more student, because we want to see the permissions on more student. We want to see this information here. Okay, so we don't get to see that. What we see is the same thing we saw here. So that's something that's important to know. In order to see information about the directory itself, you have to be one level above the directory, and then only then can you see it, I think is what they're getting at there. To avoid, or you could do this. To avoid this and query information about the directory itself, add the -d parameter to ls. Okay, that's actually kind of cool. So see how good luck getting through here. How annoying. So instead, what we could do is just go here, throw in the -d, and there we go. Now we get information about the directory itself without having to parse through this here. Really useful. Okay, so viewing hidden files. The directory listing we have retrieved using ls-l before is incomplete. So ls-l, there we go, incomplete here. We're missing a few files. There are 3 other files in that directory, but they are hidden. On Linux, files whose names start with period are automatically hidden. To see them, we need to add the -a parameter to ls. Okay, so let's try it here. So we're going to do ls-l. ls-a. So we can see here's all the files that don't show up. So let's prove it with an ls. And yep, we don't see any of those files. We can also do an ls-wc to prove it. So we got 46 lines there, -a. Now it increases to 68. Okay, as you can see, here's the hidden file. The file .this is hidden is simply hidden because its name starts with a dot, with the period character. The directory's period and period dot dot period twice, however, are special. Period is a pointer to the current directory, and dot dot is a pointer to the parent directory, the one which contains the current one. In Linux, every directory contains at least two directories. A one representing the current directory and one representing the directory the current directory is within. Tip: you can combine multiple parameters for ls and many other Linux commands. ls-l-a can, for example, be written as ls-la. So this is kind of some basic stuff. I'm kind of surprised it's coming at the end, because this is the stuff I think probably most people are familiar with coming at Linux for the first time. But yeah, so let's get something clear here. So ls, let's move into more student. Okay, and then we'll do an ls, and we'll do a ls-l. So now we've got those two extra directories showing up. We can prove that they are directories by doing an ls-al. There we go, they are directories. So let's say we wanted to do this. So we want to do the ls-d on more student. Sorry, ls-dl, because we wanted to see this information, right? But now let's say that we're in the directory and we want to see this information. Well, what do? If we do it ls-l, I don't see, it's the same thing. We don't see the directory show up here. So one thing we could do is ls-al or ls-l even dot yeah, so we could do ls-ld dot, and we can get it on the directory even though we're within it. We could also do like dot dot / more, because see that's the current one we're in. Or we could just do ls-al, and then we know that the dot is the current one. So these are 1, 2, 3, 3 ways of what we saw here, getting this same information. You could do it if you're in the parent folder. You could just do it by specifying that folder with a -d. You could do it in that folder itself by making a self-reference to it through the period. You could do it in the folder itself by giving it a path to it relative to where it is from its parent, and then calling it out and then using the -d. Or you can just know that dot is self-referential and you get the same information that way. All right, so understanding file types. We have already mentioned that the first letter in each output of ls-l describes the type of the file. The 3 most common file types are dash, normal file. A file can contain data of any kind and help to manage this data. Files can be modified, moved, copied, and deleted. D is a directory. A directory contains other files or directories and helps to organize the file system. Technically, directories are a special kind of file. L, symbolic link. This file is a pointer to another file or directory elsewhere in the file system. In addition to these, there are 3 other types that you should at least know about, but are out of scope for this lesson, and hopefully that means for the test as well, but we will see. B, so this would show up at the beginning here as an alternate option to the dash, to the D, or to the L. You could also have a B, which would stand for block device. This file stands for a virtual or physical device, usually disks or other kinds of storage devices, such as the first hard disk, which might be represented by /dev/SDA. Could also have a C, which is a character device. This file stands for a virtual or physical device. Terminals like the main terminal on /dev/gty and serial ports are common examples of character devices. And then the last one is S, which stands for socket. Sockets serve as conduits passing information between two programs. So so warning. Do not alter any of the permissions on block devices, character devices, or sockets unless you know what you are doing. This may prevent your system from working. All right, so let's try to see some of those. There are plenty in the dev folder, so let's go there. So let's do a ls-l/dev/sda. So there we go. We can see the B there because that's a block device. Let's just do it on the whole dev and see if we get any C's. Okay, so we do. So we've got these basically like console, I think that could stand for. You know, it's a terminal, so it's like it's a character device is what it means. So like you exchange characters over it, guessing. But like the VTY lines, that should be familiar from coming from like Cisco. Those are character devices. So we've got examples of the block devices, which are the storage disks. We've got examples of the character devices, which are like VTY lines. We've even got an example of a link here. We can see, and then it shows you where it is. So this is kind of like a shortcut if you're coming from Windows. You can think of that way. Yeah, and then a socket. I guess I don't see an example of that. Let's see if we can find one. So we'll do a pipe grep, and then begins with an S. Nope. So there's no sockets in there. We can do we can do it from. So where would there be a socket? Let's think of that. So let's think about that. So sockets serve as conduits, passing information between two programs. So where might there be a conduit passing information between two programs? Well, I would think that there would be one associated with this SSH connection. So let's do a netstat. And then pipe grep :22 for the port. Do a -nao. Okay, so we do have. Okay, so we have an SSH connection here. Connecting to the port here. So I would think that there'd be some kind of socket information associated with this. But I'm not really quite sure how to. So it'd be nice to find like the process associated with it or something. Oh, here we go. So we can find the program name or the process ID for the socket. So let's add a P on there. NAPO. Okay, so I think it's let's try it without the. And I'll expand this so that it's easier. So we do get an extra column here, and the column is here, but it looks like there isn't a process ID or a program associated with it. Let's see if we get any results for anything, not just that. Okay, well look at this. We do have this standard out. So let's try that. So we know we can do a ls-l d on that if it's assuming it's a directory. And there we go. Now we found that elusive S because these are netstat shows you that socket information, the conduits passing information. let's take a look at the man page for netstat. And we can see netstat prints out network connections, routing tables, interface statistics, masquerade connections, multicast memberships. So that's a good way to look at the what's going to be a socket information. So like all of this is going to be socket information. You can see this one even says socket itself. So let's run it on that, and we should see that elusive S. And if it's a directory, we have to include the D. And there we go. We've got the S. Now let's try it without the D. Okay, so that works too. It's an S. You know, it's not a directory. It's not a file. It's a socket, and we know that because of what it is there. Let's see if there's a way to see if there's like a -S with ls. Okay, there is, but it would print the allocated size of the file. It doesn't have anything to do with it being a socket. You just need that -D sometimes because the -D lists directories themselves, not their contents. So it's a special thing you need for a directory. You don't need the -D to list out a socket, a file, a block, just to see the directory itself and to override that default directory behavior of only showing the contents of the directory and not information about the directory itself. But an additional way is you just do the -A, and then you can see the self-reference to the directory through the period character. All right, so understanding permissions. In the output of ls-l, the file permissions are shown right after the file type as 3 groups of 3 characters each. In the order R, W, and X. Here is what they mean. Keep in mind that a dash represents the lack of a permission. All right. So the lack of a permission, that would mean that it doesn't have that permission. And the other, yeah, so they're going to be in order 1, 2, 3. So the first one will be the R. If there's a dash there, then that means it doesn't have write permissions. Read permissions. Same thing with the write, and same thing with the X, which stands for execute. All right, so permissions on files. R stands for read and has an octal value of 4. Do not worry, we will discuss octals shortly. That's exactly what I was worried about, is that they would be discussed. This means permission to open a file and read its contents. W stands for write and has an octal value of 2. This means permission to edit or delete a file. X stands for execute and has an octal value of 1. This means that the file can be run as an executable or script. So, for example, a file with permissions rw- can be read and written to, but cannot be executed. And that's because this dash means that it does not have the X. Alright, so permissions on directories. R stands for, and there's permissions on files. Whether it's a permission on a file or permission on a directory, it's going to be the same thing. So this is all going to be pretty much the same thing. Now remember, permissions apply to owners of files, to the groups that the owners belong to, that the file belongs to. Not that the owner belongs to, that the file belongs to. And then to everyone else. So here we're talking about permissions on different kinds of data, on a file, on a directory, on a socket, on a block, on a link, like a shortcut link. I think that's everything. Oh, on a character, I forgot about that. Like a VTY line is what that would be. So that's what we're talking about here. We're not talking about the owners, users, owners groups or global permissions. We're talking about permissions on different sorts of things. All right, so let's talk about permissions on directories. R. R stands for read and has an octal value of 4. This means permission to read the directory's contents like file names, but does not imply permission to read the files themselves within the directory. They will have their own permissions. W stands for write and has an octal value of 2. This means permission to create or delete files in a directory. Keep in mind that you cannot make these changes with write permissions alone, but also need execute permission X to change to a directory. So W means permission to create or delete files in a directory, but without X permission, you can't change to the directory to make those changes. So you can't execute the change to it. So even though you have permission to create or delete files in a directory, without the X, you do not have the means. You do not have permissions to the means to do so. All right, so X stands for execute and has an octal value of 1. This means permission to enter a directory, but not to list its files or that R is needed. The last bit about directories may sound confusing. Let us imagine, for example, that you have a directory named another underscore directory with the following permissions. So ls-ld in lowercase, another directory. There we go. So let's think about what these permissions mean. So this is the kind of data that this is. It's a directory. It could also be a file represented with a dash. It could be a block with a B. It could be a link with an L. It could be a character, which is like a VTY line with a C, or it could be a socket with a S. Also imagine that inside this directory you have a shell script called hello.sh. All right, so same thing as before. In this case, it's a dash, and then we have our 3 sets of 3 different kinds of permissions we can have. If you are the user Carol and try to list the contents of another directory, you will get an error message as your user lacks read permissions for that directory. Okay, so I am this user, so I belong in, so for this file, I'm the owner of that file, so I get these 3. I don't even have to worry about the other ones, but I do not have permission to write the file. So since I am that user and I try to list out the contents, that's a writing action. That's a reading action. So I do not have permission to read. Neither do I have permission to write. But to look at the contents of the folder, I need that reading permission. So I will get an error message as I lack read permission for that directory. Here we go, permission denied. And now remember, this comes to the standard error. So it's it's not standard output, it's standard error. However, the user Carol does have execute permissions, which means she can enter the directory. Therefore, the user Carol can access files inside the directory as long as she has the correct permissions for the respective file. Let us assume the user has full permissions rwx for the script hello.sh. She can run the script even though she cannot read the contents of the directory containing it if she knows the complete file name. Okay, so what we're going to imagine here, so we're going to think of it like this. Another directory, she does not have permissions except to execute. So that means that she can change into the directory. She can't read what's in it, but she knows in advance that this will be in there and that it will have these permissions available. So she can run the script like this, even though she does not have permissions to the directory. So you can see how that can be useful if you have other files in the directory. You don't want people to mess with. Like you don't want to see the log file. Say you're gathering statistics about like who is running this file. You can just keep it in that same directory, which would be easy when it comes to like your scripting for the files to like interact with each other and stuff. And you can keep that private from the person using their script. So important to understand and to use permissions appropriately. As we said before, permissions are specified in sequence. First for the owner of the file. So the first three here for the owner of the file. Then for the owning group. And then for other users. Whenever someone tries to perform an action on the file, the permissions are checked in the same fashion. First, the system checks if the current user owns the file, and if this is true, it applies the first set of permissions only. Otherwise, it checks if the current user belongs to the group owning the file. In that case, it applies the second set of permissions only. In any other case, the system will apply the third set of permissions. This means that if the current user is the owner of the file, only the owner permissions are effective, even if the group or other permissions are more permissive than the owner's permissions. So this is kind of hard to for me to catch on to. Let me ask the AI about this because I just feel like this part kind of went over my head. Okay. So okay, yeah. So this is just saying that it checks. So if you're the owner of the file, then it's just saying that like these don't belong to you. These are the only permissions that are relevant. If you're not the owner and you belong to the same group, then so that's all this is saying. If the current user is the owner, then only the owner permissions are effective, even if the group or other permissions are more permissive than the owner's permissions. So it only applies to you depending on what you are. It does not overwrite the permissions that you have. So like let's say the owner Carol has no permissions, but the people in the group have no permissions, but everyone else has no permissions. Well, even though you're the owner of the file, you will not have the ability to read, write, or execute, even though everyone else does. So, all right. So modifying file permissions, and I'll take a break and be right back. All right, back. Let's keep going. So modifying file permissions, the command changemod, chmod, classic command, changemod is how I call it, is used, or chmod, I guess you could call it, I don't know, is used to modify the permissions for a file, and it takes at least two parameters. The first one describes which permissions to change, and the second one points to the file or directory where the change will be made. Keep in mind that only one owner of the file, or the system administrator root, can change the permissions on a file. Oh, so that only the owner. So yeah, these permissions aren't really all encompassing. The owner who gets these three, regardless of what they are, even if it's all dashes, has special permission to change the permission. Nobody else has that, so it's just assumed and it's not even written here. The permissions to change can be described in two different ways or modes. The first one is called symbolic mode. Offers fine-grained control allowing you to add or revoke a single permission without modifying others on the set. The other mode, called octal mode, is easier to remember and quicker to use if you wish to set all permission values at once. Both modes will lead to the same end result. So for example, the command shown here. So change mode, this is in symbolic mode. So we've got UG. So this probably stands for user and group. So we've got a plus RW and then an X, and then O, we've got a minus RWX text.txt, and there we go. Chmod change mod 660. So see how much cleaner this is. It's, memorizing these probably makes sense. We'll produce exactly the same output, a file with the permission set shown here. So we know what this one is. That's not part of the permissions. That just identifies what this is. This is a file. So we can see here these numbers correspond. So we got RW, so we can see what that looks like there. It's interesting that we have an X there because there's no X in the permissions. So let's read more about symbolic mode. So when describing which permissions to change in symbolic mode, the first character indicates whose permissions you will alter. The ones for the user, for the group, or others, and or for everyone. So you can modify all three of them at once with A, as far as I know. Then you need to tell the command what to do. You can grant a permission with X, revoke a permission with minus, with the plus sign, you grant a permission, or you can revoke a permission with the minus sign, or set it to a specific value, the equal sign. Lastly, you specify which permission you wish to act on, the read, the write, or the execute. So let's go back and look at this. So we've got the user and the group. So what we want to do is for both the user and the group, we want to add, write, and read permissions, and then we want to remove execute permissions. So user and the group are here, so we can see user and the group are here, so we can see we accomplished that successfully. We added read and write, and now we removed execute. So that's why we have the X there, because we're removing it with the minus sign. And then for O, which stands for others, we're going to remove read, write, and execute so that it has no permissions. So that makes sense to me now. So for example, let's imagine we have a file called text.txt with the following permission set. So ls-l text.txt, permission set, okay. So here's the permission set. If you wish to grant permissions to members of the group owning the file, you would use the group, so that would be these here, and then you would do plus, so you want to add write parameter, so you would change this to the right. It is easier if you think about it this way. For the group, grant write permissions. So the command would be chmod g, and then grant write permissions. Let us check the result with ls. And there we go. Looks good. And you have to use the -l to see the permissions. Do you wish to remove read permissions for the owner of the same file? Think of it as for the user, and don't get confused with the O and the U. The O stands for others, all others besides the owner and the group. So to specify the owner, it's the U, it's not the O. So for the user O, revoke -sign, read permissions R. So the parameter is U-R, like so. And this is not a dash, this is a -sign. So for the user, we're going to revoke read. So there we go, chmod u revoke read. So the command is in three parts. It's who you want to apply to, it's what you want to do you want to add or remove, and it's what you want to do it to, which permission, the read, write, or the execute. Alright, so that's the user, so it'll affect these three here, and we can see we removed write, so based on what's here, it's all the same, except it no longer has write. What if we want to set the permissions exactly as RW- for everyone? Then think of it as for all A set exactly equal read R, write W, and no execute -sign. So chmod, okay, we're just going to do it for everyone. And this does equal, so we're going to set it to RW-, and now we can use this dash character because we're using the equal sign. So this isn't minus. It gets confusing if you do it that way, but that'll definitely work. So like here, you could do U- to remove R-. Well, actually, I'm not sure if you could do that there. I think you could probably only use the dash if you're using an A. I don't know. All right. So, of course, it is possible to modify multiple permissions at the same time. In this case, separate them with a comma. Okay, so we're going to multiply the owner, the user permissions. We're going to add read, write, and execute. And then we're going to do it for something else. We'll do it for the group. And we're going to remove execute permissions. So you can see we previously set it to read, write for everyone. But now we're giving execute to the owner here. And then we're revoking execute here, so that doesn't change it at all. So everything's the same except for that added execution permission to the owner of the file, who is Carol. The example above can be read as, for the user U, grant plus read, write and execute RWX permissions. For the group G, revoke minus execute permissions X. When run on a directory, chmod modifies only the directory's permissions. Chmod also has a recursive mode, which is useful for when you want to change the permissions for all files inside a directory and its subdirectories. To use this, add the parameter -R after the command name before the permissions to change. Okay. So you pass this as an option to the command. So you do it before the permissions, and then you feed what you want to change, and then you feed what you're actually changing. So this command can be read as recursively -R for the user U, grant plus read, write, and execute RWX permissions. Warning: be careful and think twice about using the -R switch, as it is easy to change permissions on files and directories which you do not want to change, especially on directories with a large number of files and subdirectories. Alright, so that's not too bad. It can get, this could be an eyeful, but when you understand what's going on, it's not too bad. But if you want it to look a bit cleaner, you can use octo mode. In octo mode, the permissions are specified in a different way as a 3-digit value on octal notation, a base 8 numeric system. Each permission has a corresponding value, and they are specified in the following order. The first comes read, or represented with an R, which is 4. Then write, W, which is 2, and the last is execute, X, represented by 1. If there is no permission, use the value 0. So a permission of RWX would be 7, 4 plus 2 plus 1, and R dash X, so no read permission, so you'd have a 0 there, would be 5, 4 plus 0 plus 1. The first of the 3 digits on the permission set represents the permissions for the user, U, the second for the group, G, and the third for others, O. If we wanted to set permissions to a file to RW space 00, the octal value would be, and let's figure it out ourselves. So first, so it would be so RW dash, so that would be a 4, a 2, and a 0, so that would be 6, 6, 0. There we go, 660. So change mod 660 sets it to those permissions. Kind of a cleaner way than all of this. Besides this, the syntax in octal mode is the same as in symbolic mode. The first parameter represents the permissions you wish to change, and the second parameter points to the file or directory where the change will be made. Tip: if a permission is odd, the file surely is executable. Oh, that is a nice tip. Okay. So which syntax would you use? The octal mode is recommended if you want to change the permissions to a specific value, for example, 640. So 6 would be the 4 on, the 2 on, and the 1 off. So there we go. Then 4 is the 4 on and everything else off, and then everything else off. The symbolic mode is more useful if you want to flip just a specific value regardless of the current permissions for the files. For example, you can add execute permissions to the user using just chmod u plus x script.sh without regard to or even touching the current permissions for the group and others. So which one would I use? It depends on what I was doing. I kind of like this one because I understand it a bit more now. I would typically use this one, but typically I wouldn't do anything that sophisticated with permissions. So I've probably used this one more than I ever would now that I've finished this lesson. So I need a quick break. I'll pause it and be right back. Okay, so I'm back. Let's keep on going. Alright, so next section is modifying file ownership. The command chown is used to modify the ownership of a file or directory. The syntax is quite simple. Chown username :group :file name. For example, let's check a file called text.txt. There we go. So we can see it's owned by user, and it belongs to by the user named Carol, and it belongs to the group named Carol. The user who owns the file is Carol, and the group is also Carol. Now we will change the group owning the file to some other group like students. So we do that with chown, and then we feed it the current user it is, and now we feed it the new group we want to it to belong to, and we can see as a result we've got the 1, 2, 3, third column or fourth column here changed to say students because that's the group that this file is assigned to. Keep in mind that the user who owns a file does not need to belong to the group who owns a file. In the example above, the user Carol does not need to be a member of the students group. The user or group permission set can be omitted if you do not wish to change them. So to change just the group owning a file, you would use chown and then :students. Okay, so you don't need to specify this. Save yourself the typing. Text.txt. To change just the user, the command would be chown, but you always do need to include this, even though you're just including the left-hand portion, you still need to have the colon to specify that there are two parts. Or just, oh no, never mind, sorry. So if it's just the left side, the owner, then you can drop the colon, or just shown there. Alternatively, you could use the command change group students text.txt. Unless you are the system administrator root, you cannot change ownership of a file to another user or group you do not belong to. If you try this, you will get the error message, operation not permitted. This is how you can make yourself feel like a hacker. Alright, so querying groups is the next section. Let's take a look at how much we got to get through. Quite a bit. I mean, some of it is just like a table that takes a lot, so there's a lot of examples too, so the reading itself might be shorter. We're at the 57, so let's get to the end of this, and then that'll be it for this part. All right, so querying groups. Before changing the ownership of a file, it might be useful to know which groups exist on the system, which users are members of a group, and to which groups a user belongs. To see which groups exist on your system, type get ent group. I'm not sure what entity maybe. The output will be similar to this one. The output has been abbreviated. All right, so let's try that on my lab because there's kind of a lot to learn here. So we're going to do get ent group. Oh, okay. And then we'll get a help on get ent. All right, so get entries from administrative database. So we see we can feed it the database. Supported databases are group right here. There's also some other ones. Let's take a look at the aliases and the hosts. Okay, and now the hosts. All right. If you want to know to which groups a user belongs, add the username as a parameter to groups. Okay, so we can say groups, and then we can add the user there, and it looks like it belongs to multiple groups. Let's try that on mine. So let's take a look at the different users. So, how can I do that? So, I'm pretty sure it's, I mean, you can see all the users on your system that way. I think with like who or W, you can see everyone currently in there. But I want to see who all the current user. I want to see all the users um, on my current system. So here we go. So here you can see um, who's on the system. Um, let's see if there's some. Okay, so let's look at man for ENT from the name server switch libraries. Now this is a host, which is kind of interesting. Tempted to just try that. Yeah, so that's not to see all the users. Okay, so this is who are currently logged in. I'd like to see just all the users, regardless of if they're logged in or not. I'm tempted to go to the AI for that one, but I won't be able to go to the AI when I take the test, so it'd be nice to see it. To be able to learn how to do it without going to the AI. But let me try WO-A. So yeah, we don't see the root user there, so I don't think that's correct. So I know if you do info, you can get this menu. So let's type in users. Alright, so that's it. Users. Alright, well I know one you can do it is you can see everyone that way. So like here's the root user daemons. So like that's one way to do it, but let's have a short conversation with the AI. So in Ubuntu Linux in Bash, you can see all of the users that are currently logged in with the command users, but how do you see all of the users that are configured on the system whether or not they are currently logged in?
In Ubuntu Linux and most Linux distributions, to see all the users configured on the system, you can check the etc. password file.
Well, that's too bad.
This file contains the details of every user account on the system. Here's how you can do it.
Yeah.
To see a list of all users, simply cat the etc. password file and look at the first field of each line. Bash copy code get etc. password get d. In Ubuntu Linux and most Linux distributions, to see all the users configured on the system, you can check the etc. password file. This file contains the details of every user account on the system. Here's how you...
Okay, so there's like no other way to do that besides looking at that file. There's not like a command for it. How come they didn't make a command for this, but they made a command for so many other things? Like, why make a command to see users currently logged in, but not make a command to see which user accounts are just sitting there stagnant that you might want to get rid of?
There are indeed various ways to retrieve information in Linux, and while the etc. password file is a primary source for user account data on local systems, there are indeed commands and utilities that provide similar information. In. This command retrieves entries from databases supported by the name service switch libraries, which can include local user accounts and remote accounts, e.g. from LDAP or NIS. To get a list of all users. Bash copy code in password kd. F1 comp gen. It's a built-in bash command primarily used for generating possible completion matches. However, you can use it to list users. There are indeed various ways to retrieve information in Linux, and while the etc. password file is a primary source for user account data on local systems, there are indeed commands and utilities that provide similar information. In. This command retrieves entries from databases supported by the name service switch libraries, which can include local user accounts and remote accounts, e.g. from LDAP or NIS. To get a list of all users, bash copy in password kd. F1 comp gen. It's a built-in bash command primarily used for generating possible completion matches. However, you can use it to list users.
Okay. I mean, I guess that kind of makes sense. Like if you put a command in real time in the CLI, then yeah, you probably want to see real time information. Like the stuff that what's configured on the system, that would be in a file. There's kind of not as much of a need to see it more like real time here and now. All right, so that makes sense to me. Yeah, so to see which groups you can use get ent group. The output will be similar to this one. The output has been abbreviated. If you want to know to which groups a user belongs, add the username as a parameter to groups. Okay, so let's try that with one of these with message bus. All right, just belongs to one group named message bus. Let's try it with the nobody group. And belongs to no group. To do the reverse, to see which users belong to a group, use group mems. The parameter -g specifies the group, and -l will list all its members. Okay, so let's try this with the nobody group. So group mems -g nobody -l. Oh, that's interesting. So group mems cannot open. Oh, you know what? Maybe I need a sudo for that. No, that's it. Oh, it doesn't exist. Okay. That's interesting because it did say that it existed there. Let's try with a message bus. Okay, so there's no users in that one. How about in this one, and then we'll try SSHD and then move on. Nothing in there. And yeah. All right. So yeah, okay. So we did that there. We see the example there. So tip, group mems can only be run as root, and we saw that there. The system administrator. If you are not currently logged in as root, add sudo before the command. Okay, so we saw that. So the next section is default permissions. It's kind of a longer section, and I'm already at the hour mark, so I think that's going to be it for part 1 of this lesson. Thanks for watching, and stay tuned for part 2.